This is worksheet 1A, internal forces. Basically, review what we learned in engineering mechanics when we learn the internal forces of a multi-force member. The first is always we need to find out the external reactions. So in the free body diagram, A at pins, so you have AY, you have AX, and if we assume the direction is X and Y, and then at B a roller, so we have BY, and if we consider the external reactions to find out AX, AY, and BY, then we consider the free body diagram for the entire structure. So it will be entire free body diagram. So what we have, if we take moment about A, assume counterclockwise positive, so you have 2 times the distributed load 2 with 9 feet, so we have 2 times 9, that is distributed load equivalent at one concentrated load, and time the moment arm is 4.5, and this one is create counter clockwise from A, so you have it negative, and then you will have the force 25 kips, and vertical it will be 4/5, 3, 4, 5, so it will be, and it also clockwise, so it will be negative 4/5, 25, and then the moment armed 6, 3, 3, 3, so it will be 15 feet, and then we plus by time the moment arm 6 plus 4, 3, so 12 plus 6 equal to 18. So from that we can get by equal to 21.16 kips positive going up based on our assumed direction. And then similarly we can go ahead to find out sum of all the force in x direction, assume go to the right equals 0, so we have AX minus 3/5, 25 kips, and from that we can have AX equal to 15 kips positive based on our assumed direction is go to the right, so it will be go to the right. And then sum of all the force in y direction going up equal to 0, that it will be AY distributed load going down 2 times 9, and then 4/5 of 25, so we have also going down 4/5 25, and we have by plus by, and by is positive 21.16 kips, so plug in, we will find out AY a positive number 16.83 kips. So just a review, nothing new for this problem, just make a warm up in here. So now they ask us to determine the internal forces at X, and this is and T, and this is multi-force member. So when you cut at S, you consider one segment the left or the right, and multi-force you have normal force, shear force, and internal bending moment. So let's do that one about S. So cut at S here, and then after that we cut at T, and let's consider the left side. So internal forces at S. So consider the left side, free body diagram. It will be here and 6 feet. So we have the dimension 6 feet, and we have A, and we have S, and when you cut at S, you will have the AY. We already find out 16.83 gibbs. AX, we have 15 gibbs, and then the distributed load after the cut is 2 gibbs for 6 feet. So we have distributed load. This is 2 gibbs per foot. And then we have normal force S, shear force Vs, and internal bending moment Ms. So from that one we can take equation, sum of all the force in x direction go to the right equals 0. So you will have 15 plus ns. So from that you will have ns equal to negative 15 gibbs. What does that mean? It's opposite to our assumed direction. We assume go to the right, so now it go to left. So 15 gibbs go left, and we need to specify on which member, on AS. And then similarly we can sum up all the force in y direction going up equals 0, and then we will have 16.83 distributed load after the cut 2 times 6, and it should be negative 2 times 6, which is 12, and then we plus Vs. And from that we will get Vs is a negative number 6.83. So you have Vs equal to 6.83, should be 4, 16.84, 83 minus 12, so it will be 4 and negative gibbs. So we have equal to 4.83 gibbs go down, we assume go up, right, on AS. So that the answer we have for normal forces S, normal force Vs. And we take moment about S to find out the internal bending moment. So moment about S to cancel out the Vs and Ns. Counterclockwise, assume positive. So from that we will have 16.83 negative. So 16.83 negative times 6, because it clockwise, and we have 2 times 6, it means 2 times 6, that is the distributed load, times 3, and that about S is clockwise, counterclockwise, so it's positive. And then we plus ms, because we assume on the out diagram it's positive. So from that we will get the positive number ms equal to the internal bending moments equal to 65.0, and the unit it keeps foot here, and if positive it means same as our assumption, clockwise, counterclockwise on AS. And of course do similarly, you can get the internal force as T, internal force at T. So let's continue quickly in here. Internal forces at T. So to cut at T here, and it's better to consider on the right side, TB, section TB, and we have only the load 25 kips going down, and then the big Y. So with that, we can have free body diagram for that one. B, you see B, and you see T, and at B we have a force BY 21.16 kips, and at 25 3 feet from B, so it's in the middle. So we have the three feet. At that 3 feet, we have a load 25 kips with the slope triangle is 4, 3, and then at T we also have NT normal force, VT shear force, and internal bending moment MT. So from that we can go ahead to apply the equilibrium equation in here. Sum up on the force in X and Y direction. X and Y direction. So sum up on the force. Let's go with X direction. Assume go to the right is positive, so you will have negative NT because go left, and negative 3 feet 25, negative 3 feet 25. So from that we can have NT equal to negative 15 kips. What does that mean? NT is equal to 15.00 kips. We assume go left, now it go right on TB. Remember TB. TB is point T and point B, not Tampa Bay, by the way. So it will be answer. And similarly, FY. So all of this you already learned. I just make it very quick in this problem. So for Fy equals 0, so we can Vt shear force at T, and then we have negative 4 feet 25 kips plus 21.16, and from that we will get Vt negative number. So from here we have Vt is negative 1.167 kips. What does that mean? Vt opposite to our assumed direction. We assume go up, so it now go down 1.167 kips going down on TB. And the last one, if we sum up all the moment about T and assume counterclockwise positive again equal to 0. So from that, you see MT, I assume clockwise, so it will be negative MT based on my free body diagram. And we have 25 kips about T also clockwise, so it's negative and 4 feet times 25 with momentum is 3 feet. And then we have the big Y 21.16 kips about T it clockwise, so you have plus 21.16 times 6 feet. And from that we can have MT is a positive number. MT equal to 67.0 keep it, and in this case it's positive, it means same as our assumed direction. As you can see here, it's clockwise, so the answer it will be clockwise on TB, and that will be the answer. So as you can see, the first problem in mechanics of materials exactly to review what we learned in engineering mechanics about internal forces, because as you can see from the lesson, we need to find out external forces and then internal forces, and then now go to the next, we learn the normal stress and shear stress to evaluate the stress and the deformation of the bodies to evaluate the performance of the bodies.